That should be us. Hot mics, everybody.
Hot mics. Hello, can anybody hear me? Yes, we are live for the first time in history.
Again.
Again. On a different channel.
Yeah, we are.
So, we accidentally put up the wrong title. We're just going to shortly fix that and then get on with the scheduled program.
Some of us have only just crawled out of bed. Me.
Yes.
It's me.
You. It still shows Game of Chess. We did some test streams where we just played some chess, so that's why that's the title. So hang on. Now it's an A. An A. Yes. There we go. Done.
Ta-da!
Ta-da!
Got there in the end. Anyway, good evening, Internet.
So we're live.
How y'all doing?
Good evening.
I'm the Howl. He's the Hoot. Some people call me Jim. Some people call me much worse than that.
But never to your face.
Sometimes to my face.
And apparently I'm Rick Ouzo, so that's me.
He's always worth a laugh. And tonight we are delving into the depths, Cthulhu style, of the flat Earth mindset. And we're probably going to have a good laugh while we're doing it.
Place.
Summon the elders.
Probably. So yeah, let's get started. And also, if anyone wanted, like, we're just picking the major trends within flat Earth, the major arguments. So if you think we're misrepresenting you, feel free to DM, and maybe somehow we can find a spot for you to come on and try to defend our misrepresentation.
We'll have a nice little interview and see where we're at. You know, we're nice people. We're not going to lambast you.
We don't want to strawman you. So if you think we are wrong in the arguments we picked, feel free, or you defend them. Feel free to defend them, either in chat or.
Why's that happened? Hold on, we're having some technical difficulties. It's been a while since we streamed seriously, about 4 years, and we're having to use a different way of doing things. Are you back, illustrious co-host?
Yeah, sorry. I'm probably going to experience some technical difficulties from time to time, apparently.
Yeah, technically speaking, he doesn't exist from a statistics perspective.
So I'm fading in and out of reality.
Yeah.
So yeah, you want to screen share again? Sorry.
Yes.
And we'll get started.
It's all right. We'll move this. We'll cut this out of editing. It'll be fine.
Yeah, it's fine.
Hey, it would have helped if I'd already started recording it for editing later. That would have been handy. I'll do that now. Do you remember the Google Hangout days where things just used to be so much easier?
They just worked. Why are we not using Google Hangout for voice? Just saying.
Because it's a bit of a nightmare to pipe onto the stream anyway, and we get better audio quality like this than we did with Google Hangouts when we tried it.
Fair enough. So yeah, start showing some images, and we'll try to. Yeah, hang on. Just gotta move my little picture out of the way. Yeah. South Pole circumference. The first argument we're gonna tackle.
And it's a good one.
So so the main, what do you call it? The main theory is that when the Earth is flat, it's all the waters are contained with an ice wall, which is what we call Antarctic, all around the Earth. But that's. Oh, hang on. Is that chat? Are
Yeah,
there actually people?
it's not on the thing.
Okay, now I'm just
It's,
out of it. Sorry,
it's all
this
good.
is our first stream. We're trying to test the what do you call it? Uh, yeah, and then make it longer.
Yeah, I know. Dude, I was gonna do it quietly. Hopefully, no one was
In the
gonna,
background.
yeah,
No.
gonna mention it. But you've lambasted that plan for me. So
Oh, sorry. Yes. So the South Pole circumference. Yeah, because on the globe Earth, it's just this ice landmass at the bottom of the globe, and in flat Earth, it's a wall or encircling the entire Earth, and that sort of makes it the easiest one to either prove or debunk, because the length of an encircling ice wall is so much longer than the circumference of a small ice. Oh, hang on, yeah, a small ice mass at the bottom of the globe. So you want to pick the next picture? Just saying, because there we go.
there we are.
So if you calculate it's a simple math circumference of a circle. If you have the radius, which is the distance from the North Pole to the South Pole, you would get a length of almost 80,000 miles of the ice wall. Whereas next picture. Yeah, when it's just the circumference of the landmass, the ice mass at the bottom, it's just around 11,000 miles. So from 78,000 to 11,000. So anybody with want to do a GoFundMe, crowdsource GoFundMe something, and rent a boat and go sailing around the South Pole, and if you get anywhere near 78,000 miles, then the Earth is flat. If you only get 11,000, the Earth is round.
Yeah, it's worth noting that if anyone does crowdfund it, I'm more than happy to come along to verify the details.
Yes, me too. I'll buy a place on the boat. No
Yep,
problem.
yep. Happily fork out for
Yeah.
that. And when we win the bet, we'll make it a bet. When we win the bet, you'll pay our expenses. So.
Yep. I'm game. A challenge has been issued.
Yep.
So yeah, that's one of the easiest of the arguments to either prove or disprove, because the difference between the circumference is so huge that even if you get 12,000 miles or if you get 75,000 miles, it's close enough that it's far enough away from each other then you know which one is true if you ever did the experiment.
By nearly an order of magnitude difference.
Yeah,
Yeah.
by almost 7 times the difference.
Yeah,
So yeah.
that's a lot of difference. That's a lot of leeway.
hmm So flat earthers, gather up some. There's plenty of gullible people who would be willing to pay for you to do this experiment.
Yeah, have a
Settle the
word.
matter once and for all. Yeah, settle the matter once and for all.
Yeah, and if if the North, what is it, the Antarctic Treaty gets brought up, don't worry, we'll speak to the respective governments ourselves to make sure that it's okay to sail around Antarctica.
Also, you're not setting foot on Antarctica. You're just sailing around it.
Yeah, you can sail around it in
So,
international waters. So,
yeah.
well, maybe there's
Or
a
you
little
can
bit of
say
Argentina that we've got to go through, but possibly New Zealand and Australia.
no, but yeah, but also like you could do it around. Like you don't have to do it around the South Pole. That was just an example. You can do it around the equator. The difference between the equator length and on a flat Earth and a globe Earth is even more stark. So if you're worried about getting shot down by gunboats or something, like some of them are, then just do it travel around the equator. See how long it is.
That might be a little trickier to do by boat, considering we'd have to cross sub-Saharan Africa.
Yeah, just do a round the world trip. Like it's all about measuring the distance. It doesn't matter if you're
Yeah,
in a boat or in a car or walking or whatever.
take some
Or
precise
do it
measurements.
halfway between the equator and the South Pole, like if anywhere you think is safe to circumnavigate the Earth. Do it, and the difference will be massive. So it'll be 100% confirmed who is right if you do that. So yeah, that was argument one, and I picked that as one because it is the easiest one to. But then there's the whole debate about globe versus maps. So yeah, first image. So this is the first globe we have in existence from 1492. It's pretty old, but nowhere near as old as the oldest maps. So Flat Earth has sort of this what do you call it? This mantra that older is better
Hmm.
for some reason. Like there was no progress in human knowledge since the beginning of time. Like we knew the most at the beginning, and then we just sort of lost knowledge as we went along instead of gaining more.
Yeah.
Flying, in contrary to all modern society, just saying. But yeah, older is better, which is why uh, we have globes from around 1492, but we have maps from somewhere about 500s
Yeah,
BC.
all the way back to the Roman Empire and before, really, of some of the
Yeah,
world.
all the way back to the Greeks. So
The Greeks. See, because I have encountered some flat Earth channels where they'll talk about the knowledge that was lost during the Great Fire of Alexandria, where the library burnt down, and it's like,
yeah,
yeah, kind of a solid argument that's very difficult to disprove, right? Because
yeah,
fire destroys everything. So it's like you might have a point that we did lose some knowledge there, but did we really lose the knowledge of the shape of the Earth when we can sort of get that back relatively easily just by having a stick in the ground at two different points on the Earth?
yeah. So yeah, next picture. Well, that's the earliest globe, and then we have the earliest pictures from around 500 BC. The earliest maps, not pictures. We didn't have pictures back then.
Yeah, cameras were not invented until last century. Well, no,
No.
1800s.
But
Sorry, century before last.
yeah, but the difference between those maps and the globe is that the globe is of the entire Earth. Maps back then were only of the known world, which is the Mediterranean. Is the in this? It's not of. There's no continent of Africa or Asia or the Americas or whatever.
Well,
It's
there's
just the
Europa and
Mediterranean.
Asia, which is actually the modern day Middle East, Arabian Peninsula, and northeastern Africa.
Exactly, and that's it. There's no the rest of Africa. There's no Asia. There's no Northern Europe. There's no Americas. There's no Greenland. There's no Australia. There's no. Although some of them don't believe Australia exists. but
We'll
that's
get
a
to that.
whole other thing to tell. Yeah, it's a whole other thing to delve into.
We'll get to that.
But yeah, you can't really compare those maps with the globe. The next image. This is sort of the first global map. It's not that accurate when it comes to the Americas, but it sort of depicts the entire globe. This is the first one. And can you tell me what year that was from?
I cannot, but I'm going to. I can
It's
have. I can
hang
have a
on. Let me
guess.
just zoom in. Now I'm gonna zoom in. Zoom in.
It's in Latin, if that helps.
It's yeah, yeah. No, it's from the Roman Empire.
It can't be from the
Late.
Roman Empire. They didn't make it as far as
No, this is from the
America.
1100s. Sorry. Yeah, yeah. This is from the 1100s.
1100s.
This
You
is
sure?
sort of. Yeah, no, it isn't. Hang on.
It's
Let me
got
look it
no.
up.
It's got to be 15th or 16th century because America's been
No, it's from.
colonized for.
Yeah, yeah. No, it's from 1536.
Yeah.
1536.
So
Which, by
post
the way, is
Columbus.
this is this is the first world map in map form. The globe was the first globe. This is about 100 years younger than the globe, and all the other regional maps can be thrown out as comparison because they're just of sections of the Earth, very localized sections. Which means, by their standards, when older is better, the globe is actually better when it comes to depicting the world. But that will require consistency. So that's probably not likely.
Well, looking at this map, actually, there is no Australia. So maybe this map is the origin of
Nope.
Australia is a myth. Unless this landmass here
Uh,
on the middle left is supposed to be Australia.
it wasn't discovered yet. No, it wasn't discovered yet, apparently. Australia, in this map. Like the ice from the South Pole is also way up towards Africa and India. So, yeah. Well, next slide. So yeah, this is the famous Peary map, which is the closest map representation to the globe. The first that is fairly accurate. And this is also the standard of all flat earthers. This is the Holy Grail that shows the flat earth with the ice wall around it.
Mm-hmm.
Except this is way, way, way younger than the first globe. So again, by their logic, if they were consistent, the Earth is a globe as well. But yeah, this is a projection map. It even says so on the map and in the patent application that this is a projection map, an equilateral distance something map. God, I can't remember. But yeah. And that means you can put anywhere as the center of the Earth, and then you can draw out the map as it would look from that point. So it doesn't have to be the North Pole as it is here. You can put it anywhere on Earth, and you can do an equilateral distance projection out from it. But this just happens to be the first one he made, the one he saw the patent application on, which is centered around the North Pole, which of course stretches the South Pole out around. Doesn't mean. But the author also believed the Earth was a globe. This is a projection of a globe on a flat piece of paper. Like all maps are projections because you can't consistently map the Earth, a globe on a flat surface. So there's going to be distortions. So on our normal maps we look at in high school and we see on the internet and so forth, the north and the south is widely distorted, which is why Greenland looks bigger than Australia and so forth.
Yeah, when it's
It
not
really
the case,
isn't.
and Africa is Africa is what
Very
14
small compared to what it is,
times
really
larger
is
than it is on the flat maps or something.
on the map. Yeah, exactly. So yeah, but this is sort of the go-to map for flat earthers. Next slide. Now we get to one of my favorite maps in the world, the flat earth.
The one
This is
on
the
the
same
wall.
lateral. Yeah, yeah, exactly. This is in the center is the map we just saw, the Piri map. But outside of it is a lot of other things. And this was supposed to have been originated from a Buddhist monk, now monastery, Buddhist monastery, and is claimed to be dated back to the 1100. Now, if you're a flat earther and you think, wow, so this is what the Earth looks like with our dome in the middle and other countries and domes and spots of lands out beyond the ice wall. Just explain to me how, first of all, we saw the map from 1500. Explain to me how a map from the 1100 drawn by Buddhist monks is so freaking accurate in the center compared to the like it's pretty much a carbon copy of the Piri map. How they knew so much about the continents and their relative positions all the way back in the 1100. Just saying. Explain that to me, and maybe then we can start talking about this map, because otherwise, that's obviously a fake.
Yeah.
Like, I'm not even gonna debate it too much. It's obviously a fake. This was not drawn in the 1100.
No.
The accuracy
Didn't this
of
first
the center.
appear in a newspaper in like 1936 or something?
Yes,
Was it the New Yorker
yes.
or something?
No, no, no. Okay, it's a Hawaii something. It was a Hawaiian newspaper.
A Hawaiian newspaper.
Uh, yeah,
So
and
then you
that
have to
was
ask the question: how
fairly
did an
known
Hawaiian
for
newspaper get Buddhist monk maps from the 11th century and had just discovered them?
exactly. And so yeah, it didn't show up in a scientific paper. It didn't. But then again, they're all lying according to them and trying to conceal the truth
Of
of
course.
this flat Earth. So it's probably why it wasn't in any scientific papers, they would say. But yeah, that's just ludicrous. That wasn't drawn in the 1100 period. There's no way the center maps of the actual Earth would be that accurate in 1100 in a Buddhist monastery.
And the ice wall is allegedly meant to be uncrossable anyway. So how would a Buddhist monk then visit these places to map them in the
Oh,
11th century before we had satellite technology or even ground-based radar?
yeah. So yeah. So that's the whole argument about maps being older, therefore better, which in reality is that maps of the world are younger, and by their logic, then worse. So they should all be globers if they were consistent. But yeah, like this one is just ludicrous. I just can't get over anyone would believe
Right.
this.
The only thing that I can think of is maybe that the newspaper that first published this as XYZ is mistaking it for some kind of astrological map that is depicting nebula just by the
Yeah, no,
shape
no,
of
no.
the
They
outlying islands. But
yeah, no, they but it's sort of a tabloid magazine from Hawaii. So they also posted about Aryan man being in the Americas around 12,000 years ago, and so for another like sort of hoaxes
yeah, sensationalist
been made
articles,
through time. Exactly.
clickbait.
So
It's the original clickbait.
exactly.
There we go.
For 100 years ago, it's nothing new and unique to the internet. So yeah, this would be like the Enquirer posted this image.
The National
or
Enquirer
something.
that doesn't actually do much inquiring. That's a different stream. Uh,
Yeah. So yeah, next image.
sun setting.
Yes. So the sun is setting, and on a flat Earth where the sun is constantly above the Earth, a flat Earth, it's sort of weird that the sun is setting below the horizon. So they try to explain it with perspective, where it just gets further and further away, and therefore gets smaller and smaller until we can't see it. So this would sort of be a sunset, according to flat earthers. A very small dot in the far distance where you can see the sun just fading away because it's too far away. That's sort of the flat Earth model, how they explain sunsets. But that's not even freaking close to what we see in real life. You want to show the next picture?
Oh yes.
That is
Oh
not a
yes, I do.
sunset.
That's such a pretty
This
picture.
is a sunset. Yes, I love it. Also, it's not a freaking fainting dot far off in the distance. Tell me that that sun is not going down behind the curvature.
That sun is
Like
not
if it
going
was
down behind the curvature.
no, because it's perspective. It's just fading further and further away
Right.
according
Yeah.
to flat. Yeah, like the first image. That's their sunset. This is reality sunset. So yeah, uh, they have some trouble explaining that, but they usually just skip over it and say more perspective, more perspective. So yeah,
Yeah. It does.
they
That's.
believe it's all perspective.
I'm mostly scientifically illiterate, but that doesn't make sense to me. I mean, that something is
That
clearly getting in the way of this rather than something moving very far away. So
yeah, and getting smaller and smaller and smaller.
yeah. Whereas this
Like
is
sunset is freaking huge, red, like a burning sun.
yeah, which is the light
Huge.
being diffracted in the atmosphere that causes it to grow red, right? Because it's the
Yeah.
angle that the light hits the atmosphere and then bounces back or something.
Like if it's way off in the sky, it only has to penetrate the atmosphere that's like right above you or almost right above you. Where it's down there, it has to penetrate all the atmosphere between you and the horizon,
Mm,
and that's a lot more atmosphere. So it distorts the light towards the red end of the spectrum
spectrum.
instead of the blue when it's right above us.
I thought the blue was the reflection of the ocean.
No,
That's what I've
oh
been
God,
told.
who did I go on stream with? Who did I
Uh,
go on stream
yeah,
with?
I've
No, it's
never
like
really
refraction,
believed it.
like here.
Or is it the other way around
No,
that the
eh,
water is blue because it reflects the sky? It could be that way around,
yes,
something like that.
yeah, because water is actually very slightly green.
Algae.
It's not colorless.
Yeah.
It's extremely minuscule amounts of green, but it's still green. But yeah, so this is the sunsets. How do you explain that on a flat Earth? Perspective. Yeah, no, that's not what it looks like. It's
No.
perspective. Just saying. Yeah.
I have watched many sunset over water in my life, and it definitely doesn't get smaller as it goes far away. From my actual observations, not even doing
No.
science. Like, I'm
Yeah,
fortunate enough to live on a
just normal.
coast, so I could go do this any night of my life, and it would not look like this, not look like the previous image even. Right, I
No.
misspoke there.
So yeah. So yeah, next one.
Earth's
Oh
going
yeah,
down.
this is a good one.
Hi.
Yeah, this is just flat earthers not understanding simple geometry. So yeah, show the first picture. This is one that they really like, and they're American, so they do it in feet. But feet is also much more impressive because there's a lot more of them in a certain distance than meters and kilometers.
Oh
So
yes.
2100, 121,000 feet. oh my God, that's high, and you can see the clouds below you, and oh my God, we are high up. And the Earth looks pretty flat. I gotta give him that. In this image, the Earth looks pretty flat from 121,000 feet.
Another spectacular
Here's
image
the
by the cameraman.
Yeah. So, but yeah, this is one of the most convincing for the flat earthers. Here's the problem. The size of the Earth is huge. I'm just letting you know right up front. The size of the Earth is huge.
Well, at least
So if you
78,000
want to show,
miles round at the pole, according to flat earthers.
yeah, yeah. So if you want to show the next image, can you see that little gray thing at the top? That's the view of that camera from 121,000. Yeah, that's what you can see of the Earth's surface. And you want to take the next image where I zoomed in on that little gray spot. Yeah, it looks kind of flat.
Yep, it does.
But this is what you see from the camera. And yeah, it looks kind of flat because you see that, go back, you see that tiny of a fraction of the Earth's circumference from that height. It's not that high compared to the size of the Earth. Yeah, so there we go. Yeah, that's why it looks flat and why that image is worthless to proving a flat Earth.
Yeah.
You need to go way higher.
I'm just
Unless
I'm trying to do the calculations of feet into miles to how high that picture was actually taken from. But I can't remember what the conversion is because we work in meters in Europe. So I think it would be a third of that.
I did the calculation. I did the calculations and calculated the angle of the circumference you could see, and then just plotted in that angle from the center and out. And that's the area you can see from 121,000 feet up in the air. Not, they could have used miles, which would have been way less impressive, even if they're American and don't want to use meters and kilometers. But yeah, it had to look very far out.
I googled it. That distance is 22.91666667 miles. So 22 miles, or if you would prefer, a quarter of the way across London.
Yeah. So if you went up 22 miles, that sounds way less impressive than 121,000 feet. Oh my God, that's a lot of feet.
Yeah, it is a lot of feet. It's not many miles, no. I mean, that's a quarter of the way to the International Space Station, which I think is about 110 miles above the surface of the Earth. You could drive there in a couple of hours, straight up.
No, you can't. You can't drive in there.
You know what I mean. Like it's
yes,
not,
I do. So.
Relatively speaking, in time, it's not that far away. Like,
no, the International Space Station is not even in space. It's still in the Earth atmosphere.
Yeah, it's above the stratosphere, isn't it? But it's within the magnetosphere.
Oh, no, it's in the stratosphere.
Oh, is it? Oh, okay.
Mm-hmm.
I thought it was just above because occasionally it skims the atmosphere, which is why they have to boost it higher so that it doesn't plummet to Earth and kill everyone on board.
Yeah. But this is what you can see, which is why it's flat in the image. Not because the Earth is flat, but because the Earth is huge. Just saying.
Yeah, ants on a snooker ball. Here, people. Ants on a snooker ball.
Exactly.
Or on a football, even. That'd probably be better scale.
Yeah. Or basketball. Yeah. Yeah, so it looks flat. Yes, this is gonna be fun. Yes, my very favorite. So next picture. So yeah, the Earth is rotating over 1,000 miles an hour around itself, And that's why flat earthers don't believe the Earth is round and is rotating. Because next picture. Because you can do this, and they don't believe you should be able to do this if the Earth is rotating at 1,000 miles an hour. This would fall over, in their opinion.
Yeah.
So that's sort of a Jenga tower is their proof that the Earth is not moving, because otherwise it will fall over. And what they don't seem to grasp, yeah, it's just ludicrous. But yeah, what they don't seem to grasp is that in a closed system, the forces within that system, it doesn't affect each other. That's why you can walk around quietly in a train that's moving 100 miles an hour, no problem. You don't get smashed up against the wall and experience the G-forces of a pilot trying to fly that fast.
Mm-hmm.
So, yeah,
So
the next picture.
hang on. There's a name for it, isn't it? Is it like relative velocity or something like that?
Mm, yeah,
Because all
you don't feel it
those,
because you're also
yeah, because we're in the environment, right?
all
We're
those.
we're already traveling at that
Yes,
speed, so we can only increase our
yeah,
own
we're
speed
traveling
relative
at the
to the
same
Earth.
levels.
Yeah.
Yeah, we're traveling at the same relative speed at the same time, so we don't feel it.
Because we're
All
already
the air molecules are
already there.
traveling along with it.
Yeah.
Yeah. So yeah, next picture. This is one of my favorite comedians has this joke about flat earthers that illustrates this point. So what is the difference between a globe earther and a flat earther?
I don't know. What's the difference between
And
a flat earther and a
yeah,
globe earther?
yes, well, you know, but
I'm doing it for the
because I
stream.
told it to you. Yes. So yeah, a globe earther is a guy who's driving along in his car at 50 miles an hour, 100 miles an hour, and turns around and sees a bee inside his car. And then he just rolls down the window and guides the bee out, closes the window, and keeps driving. A flat earther is the guy who's driving his car at 100 miles an hour, sees a bee, and starts screaming uncontrollably. It's 100 miles an hour bee!
Yeah,
Yeah,
because
exactly.
if anyone would like to work out the physics on that, it's quite simple. If the bee was in the car traveling at 100 mile an hour, flat earther thinks if the window goes down and the bee goes out, the bee will still be traveling at the same speed as the car, which bees
Yeah, no,
obviously
no, no,
cannot
no,
do.
no. No, no, no. No, no, no. The flat earther is the guy who sees the bees and sees it flying along with you, like inside the car. It's flying around, which means that you're traveling at 100 miles an hour, so it has to be too to be able to fly around and not be squashed up against the back window. So that's why it's flying 100 miles an hour.
Well, that's just what I said, but
It's
in the
traveling a
car.
lot. Yeah, inside the car, because that's when you're inside the closed system, and once you whiff it out, it's gonna be whoosh, blown back
By the
behind the
airstream.
car
Yeah.
like very fast. Yeah, because it can't keep up. But inside the car, it's fine, and it's just flying around, minding its own business. 100 miles an hour, bee!
You
Oh
love
my
that joke.
God!
He loves that joke. He tells it so often.
Yeah, yeah. Every chance like I get someone who hasn't heard it before, I tell it. So yeah, that's sort of the Jenga tower debunked. When you're inside a closed system, yeah, then there's the whole problem with the center of the Earth, which we calculate the size of using seismological equipment during earthquakes and volcano eruptions and atomic testing explosions and so forth, which sends ripples throughout the Earth. So yeah, next picture. So let's say we have an earthquake around the circle. It'll start sending ripples out all over the Earth. And then we have seismological equipment all over the Earth picking up those movements. And next picture. Yeah, and what we seem to get is that something inside the Earth is interrupting them, because we get this no readings gray area at the exact opposite side of the Earth from the earthquake, as you can see here. And on a globe Earth, that's very easily explained by the center of the Earth being a liquid, which through which the seismological waves don't travel through.
Well, I'll just stop you there. Not a liquid, a fluid.
Exactly. Sorry. Yes, not a liquid, a fluid. Yes. Yeah, because a liquid implies a lot less viscosity. So,
Yes.
yeah. No, a fluid. Yes, you're correct. It's fluid, molten. But yeah, this is what we see. Yeah, when there's an earthquake at the circle, we get this gray no readings area at the exact opposite side. On a flat Earth, next picture. On a flat Earth, this would look something like this. There's the earthquake. There, somewhere on the flat disk, which would be the opposite side of the globe Earth, you just see this dead zone from the ripples, and then they pick up again on the other side of the dead zone.
And it would be worth noting that on a flat Earth, this dead zone would move in relation to the earthquake. So you take a point anywhere on the disk, you have to add this dead zone in on the opposite side, as it were.
The supposedly opposite side, yeah.
So if
and
you
that
match
moves
up,
according to wherever. Yeah. So you could rotate this picture and have it like over to the left of where it is there, and then the dead zone would move accordingly over to the right.
So if you compiled all the seismographs from a flat Earth, all of the Earth's surface would be a dead zone. Well, all of the Earth's undercrust would be a dead zone, because you can have an earthquake at any point on the globe and it would show this. So all of the Earth is dead zone. So there is actually no earthquake.
And even yeah, please, yeah, there is no earthquakes. Try telling that to people in California.
Yeah, right. Or Tibet or something.
Yeah. Or Japan. Or...
Yeah, the Ring of Fire.
But
Italy. They had an earthquake, didn't they? Not so long ago. We've had them here in the UK. There was one in Birmingham like 10 years ago. Actually, there was one 6 miles offshore from where I live as well. A few years ago. That one shook a couple of pictures off the wall. It was most uncomfortable. So.
Yeah, but please explain how that dead zone then happens if you're a flat earther, and also why it moves around according to the where the earthquake is, and also why the ripples start being detected on the opposite side. Like, it's not like go back to the previous. Yeah, it's not like that's too far back.
Oh, sorry.
The further, yes, this one. Yeah, it's not like on this one where they sort of get cut off, and there's nothing behind on the Earth behind the. They sort of ripple out. They don't pick up behind the dead zone, and start rippling again. Well, there's just the dead zone.
That depends on the size of the earthquake or the volcanic eruption, because it can actually echo all around the Earth a couple of times, like around the core, which is actually how we map the shape and size of the core and guess its weight, is by using earthquakes.
No, hang on. Let me clarify then. There are two types of ripple effects when there's an earthquake or volcanic eruptions and so forth. And one travels alongside the surface, which you can measure all around. There's no dead zone. And then there's the ones that go through the Earth, which have a dead zone. So yeah, you can detect one type of tremors all around the Earth with no dead zone, and the other type leaves a dead zone. You can't detect them behind the center of the Earth. Whereas if you move forward, one picture. Yes. They stop in the dead zone, but on the other side of the dead zone, they just keep going. Like both waves on a flat Earth would be detectable all around the Earth, except in that little small dead zone. So explain that discrepancy in what we measure and on a globe Earth, and because on a globe Earth it's easily explainable. On a flat Earth, you really what forces are at work here? Because it's unknown forces at the moment.
We would really like to know, because
Yeah,
we could probably win some kind of scientific prize and a lot of money for it. So we would really like to know.
yeah, yes. Or if you find it out, publish it. If you found a new natural force, Jesus Christ, you would win the Nobel Prize in science.
Yeah, you'd be the richest man alive. Like Jeff Bezos, he'll have nothing on you. Like,
Yeah. So yeah, that's that's another L for flat Earth. Unless you want in the comments, explain it to us and convince us how this works.
yeah,
Go nuts.
we'll happily hear you out. Happily hear you out, and we won't
Yes.
even lambast you. We're very nice people. Well, I am. My co-host not so much.
You are. Nah, I'll be nice. Yes. So next picture. That was the whole. That's
Don't see the sun at night.
Yeah.
I like this segment.
Yeah.
I like it.
Yeah. Because this is why I really think it's bankers for flat earthers to believe in flat Earth. Like the age-old question, where does the sun go at night?
Oh yeah.
And to quote internet historian, if the universe is so big, why won't it fight me? I fucking love that guy. He's one of the funniest YouTubers.
I agree. That's if the universe
Yeah.
is so big, why won't it fight me? Just as an aside, because I believe he's Australian or a New Zealander.
Yeah, now he's Australian.
Like there's something about the
At
Australian
least he claims
sense
to
of
be.
humour. Yeah, he claims to be. Sorry,
Yeah,
he's a paid actor by NASA, really. But
Yeah,
there's just something about the Australian sense of humour that is so amazing. It's just brilliant. I recommend a channel
yeah.
called The Juice Media. They do honest government ads. It's amazing. They're putting the N back in cuts. It's absolutely fantastic. Yeah, do your own
Okay.
spelling on that so we don't get demonetized, please.
Yeah. Just a little free advertising for
Oh, technical gremlins. Hold on, he'll be right back. There you are.
So, like I said, I'm fading in and out of reality.
He's fading in and out of reality.
So, yeah, screen share again.
Oh, blimey. Yeah, I forget to do
I'm
that.
having serious problems with my computer. There we go. So, where does the sun go at night? On a flat Earth, and I realize this is a very simplified version of the flat Earth map, but it sort of illustrates my point. If you were on the dark side here, where it's night and the sun doesn't shine, why can't you see the sun still? Like you should be able to see it sideways with a pair of binoculars or a telescope and zoom in on the sun if there's no curvature. You should be able to see it from everywhere on Earth. It might not illuminate this part of Earth, but you should still be able to see it. And next picture. Now their explanation is sort of a lamp sun, where the sides of the sun, so it only shines downwards, not sideways, is covered by some substance we don't know, but it's sort of capped by something so you can't see it from the sides. And it's also why the light doesn't spread to the far side of the Earth. and only shines downwards on the half it's currently on, illuminating. That's their explanation. But that doesn't work either. That really doesn't work either. Try the next image, the next one. Yeah, because you can still see the sun on the South Pole, wherever you are on the South Pole, which means you can see the sun through the darkness, but you can't see it inside the darkness. So if you show the next picture, which is half of the year, you can see the sun all throughout the day, as you can see here. That's an image taken once an hour throughout the day. The sun is visible all through the darkness of night on half of the Earth. You can see the sun all day long for 6 months straight.
Yeah, so I'm guessing this was taken at a northern latitude somewhere. Like northern South Pole.
No, this is from south. Yeah, this is South Pole.
Oh, right, okay. Is it?
Yeah.
Huh, okay. Where's all the armed guards and watchtowers?
Yeah, I don't know. But then again, I'm not a flat earther.
Yeah,
so.
no, I was just asking out of curiosity. I mean, if this was the South Pole, I mean, there'd be attack wolves and snow plows.
There'll be
heavily armed guards
and gunboats out in the water, and
yeah, couple of aircraft carriers, like patrolling, something like that.
Exactly.
Now we're just being.
And also another problem, even if it's a coned sun, you go back one. Even if it's a coned sun, one more. Sorry. Even if it's a coned sun, like they suggest here, you would still just shining straight down. You would still be able to see it. Try the picture after the South Pole sun thing. And one more. Yeah, yeah. This is a coned light cone. This is light cone from a flashlight. You can still see it from behind it, from the side, as it goes through the atmosphere. It still illuminates particles that you can see from the side. So you should still be able to see the spotlight. Even if you can't see the actual sun, you would be able to see the entire spotlight at night with a telescope.
Indeed.
Just saying.
Yeah.
So yeah.
Just before we carry on, we'll come back to. Can we come back to the start where we're talking about perspective, and so some flat earthers may look at this image, go and say, look, the sun does get smaller in the sky. No, it doesn't. It's just dimming. The sun is the same size. This effect is caused more or less by the lens of the camera. So, where it appears the sun is getting smaller, and the atmosphere, because it's got to go through more of it. But the sun's relative size has not changed. It's just getting dimmer.
And look at the left one. There is no dispersion of light, so you just see the sun. If you look at the center one, if you look at the orange and yellow, that's all the light dispersion, which means that there are less in the center that is shown, which makes it seem smaller. But that's all the light dispersed. You can see all the yellow and red and so forth on the side.
Indeed, it's atmospheric diffraction.
Exactly. That's why it looks small. Exactly, and that's just why it looks smaller. But the picture earlier of the sunset just clearly shows that it's not very small. And you may remember this is from the South Pole, which means the sun is gonna look smaller than it does at the picture taken somewhere more close to the equator than this. So yeah, next. And next.
Yes. This is a good one as well.
Yes. Yeah. On a flat Earth, the sun changes direction and speed. It has to match observations. So next picture, just to illustrate it. So yeah, this is a picture, and we have the sun moving in circles at different times of year. So you have the equator and the Capricorn and the Cancer lines, which is what the sun is circling along. So at some point it's circling along the Cancer line hang on, circling along the Cancer line.
Northern Hemisphere.
Yeah, the Tropic of Cancer, which is summer in the Northern Hemisphere and winter in the Southern Hemisphere.
And
So next picture.
Temperature at the equator.
Yeah, so it's and then at the 6 months later, it's circling along the Tropic of Capricorn, which is summer in the Southern Hemisphere and winter in the Northern Hemisphere. So it sort of makes a larger and larger and larger circle, and then during the next 6 months, it suddenly starts making a smaller and smaller and smaller circle. Next picture. Oh, sorry, go back then. I thought there was one more image. Yeah. So it starts at the small circle, goes bigger and bigger, and suddenly it stops getting bigger and goes smaller and smaller and smaller, and suddenly it stops getting smaller and goes bigger and bigger and bigger, like every 6 months. It changes. Please, someone explain to me in the Flat Earth Society by what mechanism this happens.
Yeah, how does the sun oscillate around the North Pole like that?
Yeah. What are the natural forces that dictates this change? And also, it's a change in speed because the Tropic of Capricorn it has to travel a lot further in 24 hours. Like one rotation, one circumference is 24 hours. It doesn't matter if it's the Tropic of Cancer or the Tropic of Capricorn, which means it starts increasing in speed as well because it has to travel much further in the same time. And then it starts decreasing and moving inwards, and then it starts increasing again. So what makes it change position and what makes it change speed? I would really like some answers to that. Yes, I knew it. It's God.
Got the gaps.
Yeah, now if you say God in the comments, I'm probably not going to be as nice as my co-host to that argument.
Yeah, but believe it or not, I am the nice one. He's the attack dog. Don't let our voices fool you.
Rough.
And also if you can explain this force again, of what makes the sun speed up and slow down of its own accord, please do let science know. They will make you a very rich man, or woman, or
and also
person of other gender,
or whatever.
Take your pick.
But also where like the speed and the size of the circumference of the rotation is always 24 hours. Like that stays constant. How the freak does that happen then? Because if it's oscillating, it would be uneven. It wouldn't be 24 hours all the way through the Tropic of Cancer all the way to the Tropic of Capricorn and back. It would oscillate maybe around 24 hours, but it wouldn't be exactly 24 hours as it is in our observations. So, just saying. Yeah, that was
We'd like to know. We would like to know.
Yeah.
Right.
Yes.
Here's the teaser from earlier, everyone.
Yeah. So the sun is rising in the east and setting in the west. That's what we observe. So, next picture. If you're a guy named Bob standing on somewhere along the equator, just as it's turning into night, the sun is not setting in the west. It's setting in the northwest. The only place it's setting in the west, if you're standing on the North Pole, the further south, the further north of northwest, it's setting, and the further up, the line up if it's morning on the other side of the North Pole, where it starts to get morning, then it would rise not in the east, but in the southeast. So next picture. I just this is now the sun has moved to the other side, and it's morning for Bob standing there on the equator. And now it's rising. For Bob, it's rising on the southern part of the picture, or the lower part of the picture. Sorry. It's rising in the northeast, not in the east. Again, only the North Pole would have straight east and west rise and setting. Everywhere else would be more and more northeast, northeast for the rising, and northwest and northwest for the setting. So explain how every sunset, no matter where you are on Earth, is straight east and straight west. Because on a flat Earth, that doesn't work, as you can see. It's God refracting the light.
Must be.
Yeah. So it looks straight east, but yeah. So somebody from flat Earth, that's another point you need to explain in the comments, because it's just simple geometry. On a flat Earth, on a flat disk, this is what an Earth sunrise and sunset would look like. It wouldn't be from east to west unless you're living in the North Pole. Just saying.
Sounds reasonable to me. And that is a very sharp Terminator line as well. The night doesn't.
Yeah, no,
like
it isn't on the flat Earth. No, on the flat Earth, it doesn't look like this either. This is just to simplify, to make a point. It doesn't matter. On flat Earth, it's sort of a little more curved. So the sun is, it's like 10 degrees. The darkness is 10 degrees towards the sun on both ends of the dark half. So it's sort of what do you call those shape? A parable shape of darkness. I just made it straight to sort of simplify it and make a point, but on the so-called flat Earth models, it sort of bends a little. But that doesn't fix that problem.
Nope.
So it wasn't necessary to animate that.
Nope. I was just pointing. I was just saying it because there probably will be someone in the comments. It's like, oh, well, the Terminator line isn't like that at all. It's like, yeah, we know. There's 3 stages of night. We know.
Yeah, and I also mentioned that on the first picture of half black Earth. This is a very simplified version to prove a point to the viewer. And your curvature of the dark line doesn't fix that. So yeah, next picture.
Next picture.
Answer that for me. Yeah, this is one that I really want flat earthers. Like, forget the other stuff. Explain this one to me. If we're living on a flat Earth under a dome, explain stellar parallax. The next picture. Yeah. So the stars move, like distant stars move, depending on where you are in the seasons, meaning where you are around the sun. It doesn't matter where you stand on the Earth. They are sort of the same place because the Earth is not that wide compared to the circumference of the orbit around the sun. But if you look at it in winter and you look at it in summer, stars are completely in different places on the sky because of parallax. And parallax means that the background, the further away it is, the slower it moves. That means that when what you're looking at really close moves right past you, whereas the mountains in the background are sort of like standing still almost.
Yes.
Yeah, that's parallax. And this also means that when you look at like on a globe Earth with space, infinite space and all that, it's very easy to explain that when you go around the sun, you're in a completely different area of space in the winter and in the summer, and that's why you look at them at different angles, and they appear to have moved. On a flat Earth standing still, the sun orbiting above the Earth, please explain stellar parallax to me. Is it the dome circling around or whatever? Because that doesn't fix the problem either, just saying. But yeah, explain stellar parallax to me, because I have not found a single flat earther, and I've talked to a couple that can explain stellar parallax from their model. So please do. I really want to have a flat earth explanation for stellar parallax. Just saying. Yeah, you want to take a shot at it? You want to explain it?
I couldn't even explain parallax to you. Let alone disprove it. This is mathematics beyond my beyond my level of learning.
No, it isn't. The further away something is, the less the angle change when you move. So if you have something 100 miles away and you move 1 mile, the change in angle is not as big as if you move something. If you look at something 10 centimeters or a foot or something in front of you, and you move a mile, then it's suddenly a mile back. Whereas the thing 100 miles in the distance have maybe only moved 8-10 degrees in your viewpoint. So that's why they move at different speeds from your viewpoint.
Okay.
The distance to the. Did you get? Did that make sense? Like if you look at something 100, if you draw a line from you, like on a piece of paper,
Yeah.
and at a point far away, and then you move a little piece, then draw another line from you to that place. The length hasn't increased that much from you to that thing. Whereas if you draw a smaller line to something right in front of you and then move the same amount down, then suddenly it increased a mile in length from a foot to a mile in length, and that's a big difference. That's why it seems to be rushing by you. Whereas it might have changed from 100 miles to 101 miles. Or 100 and a half mile to the same distance, and you don't see that level. You don't experience that level of deviation. Like it's like 0.1% or so, 0.5% or something from that perspective, and you don't perceive a 0.5 difference in distance, where the closest one is like 500%. Or 1,000% difference in magnitude, and you notice that immediately.
We're back to the
So
100
it's
mile
just
an
a
hour
matter
bee,
of
aren't we?
No. Yeah. Yes, that was sort of the main. Do you have some flat Earth arguments you want us to look at?
Oh, is that it for the images?
Back at the beginning.
I don't. I thought your presentation slideshow would be enough. I mean, we filled an hour with it, which is a good thing. I think we've addressed like all of the main.
Like those are the main. Now there's way more arguments from flat Earth, but these were sort of the main ones that they sort of all subscribe to, more or less. Like there are differences in other arguments around flat Earth that maybe only some believe, but some beliefs are a hoax, and the people that believe that are NASA deep cover spies trying to infiltrate them, and a lot of paranoia going on. But those are sort of the big ones that most of them believe, and are sort of comes out naturally from a flat Earth model. Problems that come out of that I wanted to highlight and see why they were bankers as hell. Like I really don't. if we wanna if you wanna get into the psychology of flat earthers, like what the frack is making people believe in this? Like it's like sixth grade math you need to debunk this. It's not like you need complicated equations and so forth to show that.
You don't need a university degree.
It's simple geometry that you learn in like sixth grade. It's the length of the circumference of a circle. Like you can even look that you only need one parameter, the radius. That's it. And just type it in and you get the circumference. Like these are grown adults believing in a flat Earth. And I really don't get how they start believing it.
No,
Like, I guess if your parents believed it and you were indoctrinated into it from childhood, like most religion, just saying, then, yeah,
well,
sure,
that's what they
I
say
can
about
see
the
why
globe, isn't it? Is that the globe is a
Yeah.
religion. It's indoctrinated. We're surrounded by it from an early age, which is why we believe it's a globe. Let alone
Yes.
what the
But
science can prove.
I was just saying, yeah, no, but I was just saying that then I could sort of see how a grown adult could believe the flat Earth. But that's not the case. Every single one of the adult flat earthers started believing as adults.
No, I know.
And everyone around them, their family and friends, are thinking they're ridiculous. So it's not indoctrination from their wife or their husband or their parents or their sisters and brothers and uncles and aunts and friends. Like they're all laughing at them equally as hard as the rest of us. But they still believe it. And I don't freaking get why. Anybody, please explain how this comes to be, then maybe we can break them out of it. But no, I have no idea how a grown-ass adult can believe the Earth is flat.
Honestly, right, I think it may be just a rejection of authority that does it. Like, particularly rebellious people. Oh, I don't like what the government tells me. Oh, I don't trust any authority, kind of thing. Yet they're usually deeply religious conservatives. So I don't quite know how to word it other than that. It just seems to me that most of these people distrust authority. They don't like being told what to do or how to do things, so they just take what they see as gospel. So it's like they'll look to the horizon, see that it's flat, and assume that everywhere will look like that. Therefore, it is flat by their own eyes.
But flat Earth, like I
sense.
sort of get the conspiracy theory. Yeah, I sort of get the conspiracy theories around secret societies or secret government and so forth, because there's no sort of scientific disproof of it, and it's sort of just an amass of to disprove it. It's sort of just an amass of observations and argumentation and so forth to get them out of it. But so I can sort of see it's a little harder to debunk those. They're just as crackpot, but I can see why people might be convinced of those. There's nothing like if it was hard science and long equations to disprove it. Yeah, I could see why normal people wouldn't could believe it, because the Earth looks flat from our point of view. But it's simple geometry. Like 5th grade, 6th grade, simple geometry. It's that it takes to disprove it. But yeah, no, I don't get it. Like I said, I get why some people can believe some of the other conspiracy theories, but I don't get how grown adults can believe in the flat Earth. I really don't.
No, I'm with you. Like I said, the only explanation I have for it is a deep distrust of authority. That's it.
Yeah.
Like,
no, but that's why I was. Yeah, and I know we're sort of a small channel that really doesn't have any viewers at the moment. So I'm speaking to anyone listening to this in the future that if you I really meant it when I said I would love to talk to a flat earther, and I'll be fairly nice. And I might argue that your theories are wrong, but I won't attack you personally. I really want to talk to a flat earther and hear and ask some of these questions about why they believe it, how they came to believe it, who convinced them, how they got convinced, and so forth. I really want to just have a talk with a flat earther because I'm baffled. I'm really baffled. So that's an open invitation. Contact the channel and we'll set it up. We'll do an interview style live stream. So yeah, but that was pretty much. So that was pretty much what I had for this stream.
I do have a couple of questions that I'll also put out there in the public, for the flat earthers. I would like to know, if you are one of the firmament kind of flat earthers, how much does the firmament weigh, and what material is it made out of? I'm yet to come across a solid conclusion for that from any flat earther. I would also like to know, what is the substance of the foundations of the Earth in the first place that would support that weight and the weight of the Earth, if it's not a sphere? Like, what is beneath the crust?
How thick?
How thick it is.
Yes, and how thick? Yes, and what's it made of?
Yeah.
And how far out does it stretch?
Yep.
Is it just a disk with a dome above it floating in space, or just standing still, or are you one of the infinite plane earthers, flat earthers?
Yeah, or is it on the back of a turtle or a tortoise?
Yeah.
With
or
four
an elephant
carrying it? Yeah. Well, that's Discworld, isn't it? Great. Is it Greater Tuin, the world turtle? Yeah. Is it turtles all the way down? How does it work? Like, what is our place in the universe, if the universe is indeed a universe, or are we all that is in the universe? In which case, can you explain to me how we can tell the mass of distant stars? That would also be another question that I would like an answer to. How do you explain us being able to tell the mass of distant stars, including our own, which is 99.9%
but all these questions
of the solar system?
Yeah, but also this is why, please, if you're a flat earther, contact us, and we'll love to talk to you and ask you some questions.
We really would. We won't like call you bad names or anything. We're knowledge seekers more than anything.
And we'll just we might throw in some science disproving some of what you're saying, but we won't attack you personally.
No, we're not gonna ad hom. We're better than that. Well, I certainly like to think so. We might ad hom each other. But,
but that's just for fun.
Yeah, well, I mean, he's an idiot, so.
Well, technically I am. So yeah.
Yeah, we know nothing. We would like to find out more. So.
Yeah, no, that's fair.
We're good mates, really. Trust us. Until he beats me at chess again.
We're gonna do some streams of that as well.
Oh yes.
At some point. So look forward to that in the future. We're gonna do where I completely trounced. Well, he's gotten better very quickly after I taught him some things, but I'll still trounce him.
Oh yeah, for sure. I don't anticipate being able to beat you for at least a year.
We'll just get some games in. But we'll talk about that on the chess stream.
Yes, we're Flat Earth. I suppose at some point we'll be back with another area of things that we would like to know about. We'll have to have a little discussion on that and schedule something. I'm sure there are other things out there in the world that we can talk about. Young Earth, but
it'll probably be it'll probably be next week. Next weekend.
Next weekend. Same time, same place, same channel.
Yeah. Yeah, Saturday, around 8 p.m. So Central European time.
If I wake up in time and get my coffee, we.
Yeah, yeah, like. So
So
yeah. Well, I've been Rick Ouzo. I'm not promoting another channel, so
you're promoting this
who are
one.
you? Yes, please subscribe and like or dislike if you're a flat earther.
And
That's fine.
and if you're a graphic artist,
Still
get in
love you.
touch. We may have a commission for you.
Yeah. And you are?
I'm Jim Michelson, although people call me a lot worse things. I'm the Howl. He's the Hoot. We'll be back next week.